In this video, I'm going to show you how to simulate a pneumatic indexing table inside ProtoTwin. By the end of this video, you should understand a lot of the key concepts that you can apply to create a simulation of your own machine. We'll start by importing the CAD for the pneumatic indexing table directly into the main application. If you wish to follow along, you can find a link to the CAD in the video description. After the CAD has been successfully imported, we can begin to add behavior to parts. I'll first hover over the part I want to select, then Control right-click and select Assembly 1. I'll now add a physics component to this entity and set the collider to None, since we're not interested in modeling collisions. I'll then add a joint, leave the constraint as Prismatic, and select the axis of motion by hovering over a feature of the mesh. Next, I'll add joint limits. I'll first enable the lower limit and leave its value as 0, then enable the upper limit and set its value to 0.1 meters. I'll then select the second assembly and once again add a physics component with the collider set to None. I'll then add a joint, set the constraint type to Revolute, and configure the axis and anchor properties. I'll now select the base and choose Assembly 1. Doing this specifies that the joint for Assembly 2 is attached to the joint for Assembly 1. If we run the simulation, we can interact with the physics to test the joints. As you can see, the joint limits are being applied correctly, and the joints are also chained together to form a linkage. I'll now reset the simulation and swap back to edit mode. I'll now select the third assembly, then add a physics component once again with the collider set to None. I'll then add a joint, set the constraint type to Revolute, and configure the axis and anchor properties by selecting features from the CAD. For this joint, I'll set the base to Assembly 2, which specifies that the joint is connected to the link for Assembly 2. I'll add another Revolute joint and configure the axis and anchor properties again, with the base left empty. This will permit rotation about the anchor point and around the axis we selected. Next, I'll select this rod entity here, then add a physics component with the body set to Attached and the collider left as Convex. Attached specifies that the entity has no rigid body, but that its collider is attached to the rigid body of the parent. I'll Control right-click again and select Assembly 4. Once again, I'll add a physics component, set the collider to None, then add a joint, set the constraint type to Revolute, and configure the axis and anchor properties. Adding physics to Assembly 4 ensures that the mobile table, which is a child of this entity, is allowed to rotate. I'll now select the wheel, which is another child of this entity, then add a physics component with the body set to Attached and the collider set to Custom. Doing this will upload the mesh for the wheel and download it directly into ProtoTwin's custom collider tool. I'll now change the collider type to SDF and then click the Generate button to generate the Sign Distance Field collider. You can then click the Save button to upload the collider from the tool and download it back into the simulation environment. With the physics now correctly configured, we still need to decide how to control the machine. I'll first go ahead and select Assembly 1, which, if you recall, is the entity that has a prismatic joint. I'll then open the joint and click the Add button next to the motor property to create a motor component that is bound to the joint. I'll then change the target velocity to 0.5 meters per second and the target acceleration and deceleration to 0.5 meters per second squared. I'll then add a sequence component to this entity, which we'll use to control the motor. I'll first add a Move To operation, then select the motor and set the value to 0.1 meters. I'll then add another Move To operation with the same motor selected and the value set to 0 meters. This will instruct the motor to drive the joint to 0.1 meters, then back to 0, then to 0.1, and so forth. With the model setup now complete, we can run the simulation to test the machine. The back and forth movements of the prismatic joint translate into a continuous rotation of the rod. This then gets converted by a Geneva mechanism into a controlled intermittent rotation of the wheel for indexing the table. Hope this video was helpful. Thanks for watching.